Welcome to ROAV Perfect classes. In this video, I will discuss about operating system. About operating system. This subject is most important for B.SC, BCA, PGDCA, MSC, MCA students. So that's why I am discussing about operating system in this video. Now, first of all, what do you mean by operating system? Operating system is an interface. Operating system is an interface between user and hardware, and it provides an environment. It provides an environment to the user. User means applicant who use the system. The user can perform its task in convenient and efficient way. Means a person who use the computer, that person can perform its task in convenient means in easy way and in efficient way. Can perform its task in a easy way. The operating system is divided into various parts based on its function, like process management, process synchronization, deadlocks, and file management. These are functions which are performed by operating system. Now, next, structure and working of operating system. Operating system is an interface between user and hardware. Here you can say user and hardware. Between user and hardware, operating system performs a role and whose responsibility for execution of all the processes, and operating system is responsible for resource allocation, CPU management, file management, and many other tasks. The main purpose of operating system is to provide an environment in which a user can execute programs in a easy way, in a efficient way. A computer system includes user, software, that is known as application programs, and third, system programs, fourth, operating system, fifth, hardware. So we can say that a computer system includes users. User means those people who are using the computer. And application programs means compilers, means compilers, databases, compilers, databases, games, video player, browsers, Microsoft Office, any type of application which are used by a user for doing any work, for doing programs, for making new softwares, those are known as application programs. Now next is a system programs. System programs means those programs which are shells, editors, compilers are used by the application programs for executions of their instructions, their programs, that is known as system programs. For example, shells, editors, or you can say compilers. These are system programs which are used by application programs for execution of their programs. Now next is a operating system. Operating system is a special type of program which works as an interface between the user and hardware. Between the user and hardware. It is just like a bridge, just like a interface. And next point is hardware. In hardware, we can say CPU, disks, memory, etc. These all things are called hardware. Now, next point is what are the functions of operating system? Before going to start, what are the functions of operating system? We have to think about what does an operating system do? Means what type of functions an operating system can do. An operating system can management of process. An operating system can do synchronization of process. An operating system can do management of memory. An operating system can do CPU scheduling. An operating system can do file management. An operating system can do security. Now, next point is types of operating system. Types of operating system. In types of operating system, we can say that an operating system is a well-organized collections of programs. An operating system is a well-organized collection of programs which used to manage the computer hardware. Means an operating system is a collection of programs which are used for managing the computer hardware. And we can say that it is a type of system software because it is responsible for the smooth working of a computer system. Smooth working of a computer system. computer system. There are different types of operating system. First is batch operating system, second multitasking operating system, third multiprocessing operating system, fourth network operating system, fifth time sharing operating system, sixth distributed operating system, seventh real time operating system, eighth multi-programming operating system. Now first point, batch operating system. Batch operating system was very popular in 1970s. In this, same type of work, same type of jobs were batched together and they execute in a time. In this, people who were used to having a single computer, which was called a mainframe, mainframe. People who used to a single computer, that is known as mainframe computer. In batch operating system, access is given to more than one person. Access given to more than one person. They submit their jobs to system for the execution. We can say that in a batch operating system, access which is given to more than one person, they submit their job to the system for the execution. After that, the system put all of the jobs in a queue. System put all jobs in a queue, and after that the system use first come first service method. First come first service method for the execution of jobs. For the execution of jobs one by one. Means the system keep all of the jobs in a queue. Then use first come first service method for the execution of jobs one by one. The users who collect their output when all jobs get executed. Means in batch operating system, first of all, access is given to more than one person. Then they submit their jobs to system for the execution. Then system put all the jobs in a queue on the basis of first come first service. Then they execute the job one by one. After that, users collect their output when the all jobs are executed. That is known as batch operating system. The main purpose of this operating system to transfer the control, the control from one job to another job as soon as possible job was completed. The main purpose of batch operating system is to transfer the control from one job to another job as soon as the job was completed. And we can say that in batch operating system, it included a small group of programs. Small group of programs. Small group of programs. And a small group of program is known as resident monitor. Is known as resident monitor. Known as resident monitor who always resided in one part of the main memory. Resided in one part of the main memory. And the remaining part of CPU is used for servicing jobs. We can say that the main purpose of operating system is to transfer the control from one job to another job when the job was completed. And after that, it includes a small group of programs that is known as resident monitor, and that program is resided, that monitor is resided one part of main memory and other part of memory is used for servicing jobs. Now, what are the advantages of batch operating system? The batch operating system main advantage is that it is used to improve the computer efficiency. It's used to improve the computer's efficiency. That is the main advantage of batch operating system, because it eliminates means it removes the CPU time between two jobs. The main advantage of batch operating system is to improve the computer efficiency, as it removes CPU's time between two jobs. But within advantage of batch operating system, there are some disadvantages of batch operating system. That is starvation. Batch processing suffers from starvation. For example, there are 5 jobs. Job 1, job 2, job 3, job 4 and job 5. There are 5 jobs. Job 1, job 2, job 3, job 4, job 5. They are present in a batch. If execution time of job 1 is very high, then other four jobs will never be executed. Then other 4 jobs will never be executed, or they will have to wait for long time, very long time. Other processes get stopped. At the end, other processes get stopped. That means, for example, job 1 takes time 10 minutes or 10 seconds. And job 2, job 3, job 4, 5, These jobs take time 3, 4, 5, 6 seconds. But job 1's time is very high and he takes the time for execution very long. And after when it takes the time more, then other jobs will wait. And when other jobs will wait for a long time, then these jobs get starved. That is known as starvation. Now next, it is not interactive. Second disadvantage is that it is not interactive. Why? Because batch processing is not suitable for jobs which are dependent on the user's input. Batch processing is not suitable for those jobs who are dependent on the user's input. If job which requires the input of two numbers from individually, then it will never get it in the batch processing scenario because the user is not present at the time of execution. Means batch processing which is not suitable for those jobs who are dependent on the user's input. If user is present, then that user can give the instruction, then that user can give input. But if user is not present at the time of execution, then it will not interact itself. So we can say that this is the second disadvantage of batch processing, that is, it is not interactive. It is not suitable for those jobs who are dependent on the user's input. Now next point is multitasking operating system. In multitasking operating system, we can say that multitasking operating system means it is a logical extension of a multi-programming system. It is a logical extension of a multi-programming system which enables multiple programs simultaneously, at a same time. It permits a user to perform more than one computer work at the same time. Multitasking means when an operating system performs multiple tasks at a one time. For example, your CPU is used for listening music, for working in MS Word, for sending email, for working on internet, on web browser. That is known as multitasking. So we can say that it allows a user to perform more than one task at a one time. That is known as multitasking operating system. But there are two types of multitasking operating system. That is known as preemptive multitasking. Second is cooperative multitasking. cooperative multitasking. There are two types of multitasking. First is preemptive multitasking and second is cooperative multitasking. Now its advantages. When we use multitasking operating system, then we can say that it has some advantages. That's why we use multitasking operating system. That advantages are: first, it is most suitable for supporting multiple users at a same time. Second, it has well-defined memory management. It has well-defined memory management. These two advantages of multitasking operating system. First is, it is suitable for supporting multiple users at the same time. Second, it has well-defined memory management. But it has one disadvantage, that is multiprocessors are busier at the same time. To complete any task in a multitasking environment, then CPU generates more heat. If we take CPU multiple tasks at the same time, then it will generate more heat. That is the disadvantages of multitasking operating system. Now next type of operating system is multiprocessing operating system. In multiprocessing operating system, parallel computing is achieved. So there are more than one processor. More than one processor present in the system, which can execute more than one process at the same time. This will increase the throughput of the system. In multiprocessing system, parallel computing is achieved. There are more than one processors present in the system and they can execute more than one process at the same time, and by this it increases the throughput of the system. And we can say that there are two types of multiprocessing system. First is symmetrical multiprocessing system. Second is asymmetric multiprocessing system. Symmetric and second is asymmetric. Operating system. Now its advantages is it increased reliability. It increased reliability. Second, it increased throughput. How it increased reliability? Due to multiprocessing system, the processing tasks can be distributed among many processes. The processing works can be distributed among many processes, and it increases the reliability. If one processor fails, then work can be done by other processor for the completion. So that's why it increased reliability. I again repeat, how to increase reliability? Because we use multiprocessing system. In multi-operating system, processing work can be divided into multiple processors, And if one processor fail to do work, then other processor can do that work for the completion. That's why it increases the reliability. And second point, according to second point, it increased throughput, or you can say that throughout, means many processor increase, more work can be done in a less. So that's why it increase the throughout or throughput. But its disadvantage is that it is more complex and it takes care of multiple CPUs simultaneously, because here we use more than one CPU. So that's why we have to take care of multiple CPU at the same time. So that's why it is more complex and soft, and it is more used at the same time, more than one CPUs. It creates the complexity. This is the disadvantages of multiprocessing operating system. Now next is network operating system. A network operating system, we can say that an operating system which include software and associated protocols to communicate with other computers by a network in an easy way and in an effectively less cost. That is known as network operating system. Means this is a server software which is connected with other computer system. These are known as client computer. Means in a network operating system includes software and associated protocols for the communication with other computers through the network in easy way and in a cost effective way. It is known as network operating system. There are two types of network operating system. First is peer-to-peer system, that means one-to-one. And second is client server operating system. Client server operating system, that means one server and multiple clients, or you can say one server to one client. Now its advantages is that it reduces traffic of network due to division between clients and server. In this type of operating system, network traffic reduce. Network traffic reduce. Why? How to reduce? Because it divided between the clients and server. Secondly, it is less expensive to the setup and maintain. This is the advantage of network operating system. Now disadvantages of operating system is, network operating system is, in this type of operating system, if any node is failure, then it affects the whole system. If any node is failure, then it affects the whole system. Second, security and performance are most important problems of network operating system. It requires trained network administrators so that they can manage whole network operating system. So that's why we can say that these two are disadvantages of network operating system. Now next point is time sharing operating system. In time sharing operating system, we can say that CPU is one CPU is shared by multiple users, but by dividing time. Means in time sharing operating system, computer resources are allocated in a time dependent fashion to many programs at a same time, and it also helps to provide large number of users direct access to the main computer. It is a logical extension of multi-programming. In time sharing, we can say that CPU is switched among multiple programs by multiple users, by different users on a scheduled basis, on a schedule basis. Means in a one lab there are 10 users who wants to use one system. They have it 60 minutes for complete a work. 10 minutes are given to each user for doing their work. Means there is using time sharing operating system because CPU is switched among these 10 users after 10 minutes on their scheduled basis. In other way, we can say that in a time sharing operating system, computer resources are shared by multiple users by switching the CPU on a different time basis, on a schedule basis of a time. A time sharing operating system allows multiple users to work simultaneously. That is here, so we can say that here we use CPU scheduling scheme. CPU scheduling scheme. We use here CPU scheduling scheme and input-output management. These systems are very difficult and these are very expensive to build. But there are some advantages of this type of system is that it provides effective utilization and sharing of resources. Second, system reduces CPU idle time and it gives the response time. But disadvantages of time sharing operating system is, first, data transmission rates are very high in comparison to other methods. Second, security and integrity of user program which are loaded in the memory and data which is needed to be maintained as many users access the system at the same time. So that's why these are disadvantages. Now next is a distributed operating system. In a distributed operating system, we can say that distributed operating system is not installed on a single machine. Not installed on a single machine. Not installed on a single machine. It is divided into parts. It is divided into number of parts. And these parts are used for loading the work on a different machines. One part of distributed operating system is installed on every machine for making their communication possible. And these type of distribution system are much more complex, more large and sophisticated as compared to network operating system. Reason? Because they also have to take care of changing network protocols. Changing network protocols. If one lab we use LAN protocol, we use LAN method, that is known as local area network method, and local area network is communicate with other side lab with their host by using gateway that is known as distributed system. We can say that in a distributed operating system, work is divided into parts and these parts are loaded on the different machines, and one part of distributed operating system is installed one machine to make their communication possible. But this type of operating system takes the more time. These type of operating system more complex, more large as compared to other operating system because they need to changing networking protocols. They need to take care of changing networking protocols. Advantages of this type of protocol, this type of operating system is it provides sharing of resources. You can share, for example, in your lab one printer is present. You want to share that printer with the other you want to share that printer with other users. Then we use the distributed operating system method. And second is this type of system is fault tolerant method. This type of system is a fault tolerant. And disadvantages of this distributed operating system is protocol overhead, protocol expenses can dominate the calculation cost. This is the disadvantages of distributed operating system. Now next type of operating system is a real-time operating system. In real-time operating system, we can say that every job carries a certain deadline within which they have to complete their job. In real-time system, every job carries a certain time of deadline within which that job will be completed. Otherwise, they have large loss, huge loss, and even the result is produced that will be completely useless, because if result is not getting on time, then that result will be completely useless. So that's why in real-time system, every job should be completed within the deadline time. Should be completed within the timeline, otherwise that work will be useless. Application of real-time system exists in the case of military applications. There are so many examples of applications of real-time system which are we today using. If we want to drop a missile, then there is an example of military application. In this we say that if we want to drop a missile, then missile is supposed to be dropped within a certain precision, certain time. And there are different types of real-time operating system. First real-time operating system is hard real-time system. hard real-time system. Second is a soft real-time system. Third is a firm real-time system. Firm real-time system operating system. Now the some advantages of real-time system, real-time operating system, that is easy to lay out. It is easy to lay out. It is easy to develop. It is easy to execute real-time applications under the real-time operating system. Second advantages of real-time operating system is that it is used to maximum utilization of devices and systems. Disadvantages of real-time operating system is these type of operating systems are very costly to develop. These type of operating systems are very complex. They can consume more CPU cycles, more critical CPU cycles. Now last operating type of operating system is multi-programming operating system. In multi-programming operating system, we can say that we use batch processing system, but multi-programming is the extension to batch processing system where CPU is always kept busy. And every process requires two types of system time. First type is CPU time. And second is input output time. In multi-programming operating system, when one process does its input output, then CPU starts the execution of other process. So multi-programming improves the efficiency of the system, and its advantages are first, it increases the CPU throughput because it always had one program to execute, and it also reduces the response time. But its disadvantages is that various system resources which are used efficiently, but they do not provide any user interaction with computer system. Whether many system resources are used efficiently in multi-programming system, but they do not provide any type of user interaction with computer system. These are the types of operating system which we discussed. Now, next point I am going to discuss that are process management in operating system. Process management in operating system means a program does nothing till instructions are executed by a CPU. Till its instructions are executed a CPU means when a CPU execute instructions, then a program do something. A program in execution, that is known as process. A program in execution, that is known as process. And in order to complete its task, its work, process needs the computer resources, needs the computer resources. We can say that a program is nothing if instructions are not executed by CPU. When a program is executed, then we can say that that is a process. And when program is completed their execution, then process needs the computer resources. So we can say that there may exist more than one process in a system. Means in one system there can be more than one process and they need same resource at the same time. We can say that in a system more than one process, in a system more than one process needs same resource at the same time, at the same time. So operating system has to manage all these processes. So operating system needs to manage all these processes and the resources in a efficient way, in a convenient way. Some resources they need to be executed. There are some resources they need to be executed by one process at one time. Some resources they need one process can execute at a one time. So we can say that some resources they may need to be executed by one process at one time to maintain the consistency. Why we need for the consistency? Otherwise system can become inconsistent or it create deadlock. So we can say that for reducing the deadlock we have to use one process at one time. Now next point is in process management in operating system is responsible for following activities like scheduling processes, threads on the CPUs. Second, creating and deleting both user and system processes, suspending and resuming processes, providing mechanism for process synchronization, and providing mechanisms for process communication. These are the some activities which are doing in a connection with process management and which are managed by the operating system. These are managed by the operating system. Now I am going to discuss about what types of attributes of a process is used. First, process ID, second program counter, third process state, fourth priority, fifth general purpose register, sixth list of open files, seventh list of open devices. First, process ID. Process ID means when a process is created, a unique ID is given. Unique ID is assigned to the process that is used for unique identification of the process in system, that is known as process ID. When a process is created, then a unique ID is generated and that is assigned to the process, and that is used for the unique identification of the process in the system. Second point is program counter. Program counter stores address of the last instructions of process on which process was suspended. Program counter stores the address of last instructions of process on which process was suspended. The CPU uses this address. When the execution of this process is resumed. Now third is a process state. The process from its creation to completion. Goes through the various states. For example, these states are new, ready, running, and waiting. Now next point is priority. Priority means every process has its own priority. The process with its highest priority among the processes gets the CPU first. Whose priority highest, that will use CPU. Now, this is also stored in the process control block, that is known as PCB, process control block. Now next is a general purpose registers. Every process which has its own group of registers. It has its own set of registers which are used to hold the data and which are used to generate during the execution of process. General purpose register has many registers, and these type of registers are used to hold the data and used to generated during the execution of the process. Now next is a list of open files. List of open files during the time of execution, every process uses some files and which need to be present in the memory. And these files are maintained by the operating system in PCB. These files are maintained by the operating system in PCB. Means when we execution any files, then they need to present in the main memory, and operating system maintains a list of open files in the process control block in the PCB. Now next is a list of open devices. Operating system also maintain all the list of open devices which are used during the execution of process. when used in the execution of process. During the execution of process, all open devices are maintained by the operating system. Now, next point is process states. How to work operating system, how to process work, what are the process states which are used in the process states. First, the process from its creation to completion. From its creation to completion passes through the various states: new, ready, run, wait, block, suspend, wait, suspend, ready, etc. The minimum number of states are 5. The names of states which are not standardized, they may be used in the during executions. First is new. First state is new. When a program is created, a program which is going to be picked up, which is going to be created by operating system into main memory, that is known as new process. This is known as new process. After that, this process goes to in ready state. Goes to in ready state. Whenever a process is created, it directly enters into ready state, in which it waits for the CPU. Here it waits for the CPU. It waits for the CPU to be assigned. The operating system picks the new process from secondary memory and put all them in the main memory. From secondary memory to main memory. Operating system takes this new process from secondary memory and put into main memory. The processes which are ready for execution, those processes which are ready for execution and they reside in main memory. They are ready for execution, they reside in main memory. That is known as ready state. There can be many processes present in ready state. After that, running state, that is known as run. That is running state. One of the processes from ready state will be chosen. When from this state one process is chosen, that depends upon the scheduling algorithm. If we have only one CPU in our system, then number of running processes for a particular time, they will always be 1. If we have number of processors in the system, then we can have number of processes running at the same time. In a block or wait system, after running in running state, some processes need to wait. Means from running state, a process can make the transition to the block or wait system, wait state, and it depends on the scheduling algorithm. When a process waits for a certain resource to be assigned for or for the input from user, then operating system moves this process to block or wait state, and after assign the CPU to other processes. And next is a completion or termination. Completion or termination. When a process finishes its execution, then it comes into termination state. All the context of process will also be deleted from the process that will be terminated by operating system. But sometime in a running state, when it goes into waiting state, they will be goes to block. After block, sometime they will be suspended or sometime they will be resumed. When they will be resumed, they goes to again for either in the ready state or suspend state. If they go in the ready state, then it will be resume and go into ready state, and again processing is starting. Process is starting and it goes goes into the running state, and after the execution of program, when the program execution is completed, then it goes into termination state. If after in a running state, it needs the input output request, and when it needs the input output request, if they get the input from the CPU from the user, then it will go for the ready state, and when it will go in the ready state according to scheduled or dispatch time, that will be sent to the running state. But sometime it will not go, will not go in a wait state. It will go into again in the ready state for according to priority or time quantum. And after that, sometime in a ready state, some time it ready state, it will not get the any instructions, then it will go into suspend state, and in the suspend state it will be suspended, or sometime it will be resumed when they get the resource. And after getting the resource, then it will go into ready state again, and it will dispatch to the running state, and running state to termination state when it complete their execution. And this process, these all states are working in a cycle form. Process completed when it in the suspend or wait state, then it will the process completed input output, but still in a suspend state, then it will go in the suspend or ready state, and when they get the input output resource, then they get the source, and they will resume and go into the ready state. Now you can say that suspend ready and suspend wait means, in suspend ready, when a process in a ready state, they move to secondary memory, moved to secondary memory from the main memory, and due to lack of resources, that is known as suspend ready state. Means we can say that new process is created. First it goes into ready state. When it is in a ready state, but it needs some resources, but that resources are used by other process, then sometime it goes into suspend state, suspend or ready state, from memory from main memory to secondary memory, due to lack of resources. If main memory is full and higher priority process comes for the execution, then operating system have to make room for the process in the main memory by throwing the lower priorities process out into the secondary memory. The suspend ready processes remain in the secondary memory until the main memory gets available. These from this ready state to process goes into suspend or ready state. In this, from this state to state, the process goes into secondary memory state, and where it will remain till time when they get the again resources, and it goes into after assuming it go back to the ready state. Now second is a suspend wait. Suspend wait means instead of removing process from ready queue, instead of removing from ready state the process, thus it's better to remove the blocked process which is waiting for some resources in the main memory. Since it is already waiting for some resource to get available, and hence it is better if it waits in a secondary memory and make room for higher priority process. These processes complete their execution once main memory gets the available and their wait is finished. Now I will repeat whole process again. I will repeat again what is a process states and what are the process states, how to use it, how to work these process states. I will discuss again these points because these are most important and these are very, very important for the exam point of view. I can say you have to keep in mind that first of all process creates, then when process creates, then from secondary memory to main memory it transfer. In main memory ready state, the process goes into ready state if it has it available in ready state. If available resources for this new created state, then it will use it and dispatch that process in the running state. When it dispatch into running state, if it work complete, then it will be terminate. Otherwise it will go back to ready state or it will go to the wait or block state. It will go into wait or block state when it requests input resources, and input resources are not available. They are using by other resources. When they release, then it will be used. So that's why the process goes into wait or block state where it waits for the resource free. If resources are free, then they takes the resource and go back to the ready state. And after this, again scheduler dispatch that process in running state. If work is completed, then it will be terminate. On the other side, when process creates, it goes into ready state. In a ready state, there is not available any resource free, then it will go into suspend or ready state. When it go into suspend or ready state, it will be sent from main memory to secondary memory. If secondary memory is full, then secondary memory exerts the lowest priority process out of the secondary memory and gives the space in secondary memory to those processes who has highest priority. When these processes in secondary memory if they get resource, then they will go into again after resuming in ready state. And when they go into ready state, then scheduler send to it running state, and after completing work they will be terminate. But on the other side, when process is in the running state and from running state it goes into wait or block state. In wait or block state, either it will wait for resources or sometime it will be suspended for some time. Then it will goes into suspend or wait state, where it wait. After waiting some time, it will resume again and goes into wait or block state. And after that again for some time, after some time it will again goes into suspend or wait time. Or when process completed input output process, means it will take the resource but still in suspend mode, but still in suspend state, then it will goes into the suspend or ready state. There it will resume, and after resuming it will goes into ready state, and in ready state it will goes in, after that it will goes into run state. It will dispatch into run state, and where it will work complete, and then it goes into termination state. And from ready to running state, the work will be done on the priority base. On this, sometime work on the priority base, time quantum base, sometime it will first come first service base, or there are many other algorithms which are used for the CPU scheduling algorithm.